Continuation of the previous problem number 4. Here Bn is equal to 2 into 3 6h by L square into, now here substitute upper limit minus lower limit. Now upper limit minus L by 3 into cos of n pi by L into L by 3 by n pi by L, minus of minus plus lower limit 0 into cos 0 by n pi by L, 0 into cos 0 1, that is a 0. Now Bn is equal to 6h by L square into minus L by 3 into cos of n pi by L into L by 3 whole divided by n pi by L minus of minus plus 0 into cos 0, that is 0 into 1, 0. Now here substitute upper limit minus lower limit, that is sin n pi by L into upper limit L by 3 minus lower limit sin of 0, that is also 0, by n square pi square by L square minus 0. Sin of 0 is 0. Here L gets cancelled. Here also LL gets cancelled. Now here upper limit 2L by 3 minus of L minus 4L by 3, that is by taking LCM 3L minus 4L, that is minus L by 3, minus into minus plus cos n pi by L into 2L by 3 by n pi by L. Next, minus of minus plus lower limit L minus 2L by 3, that is 3L minus 2L, L by 3 into cos n pi by L into L by 3 by n pi by L, plus L by 3 into cos of n pi by L into 2L by 3 by n pi by L. Here LL gets cancelled. Now next term minus of minus plus L minus 2L by 3, that is L by 3 into cos of n pi by L into L by 3 lower limit by n pi by L. In this term substituting upper limit and lower limit, now minus 2 into sin n pi by L into 2L by 3 by n square pi square by L square, minus of minus plus 2 into sin n pi by L lower limit into L by 3 by n square pi square by L square. Again I am showing this 2 into sine 2n pi by L into upper limit 2L by 3 by n square pi square by L minus of minus plus lower limit 2 into sine n pi by L into L by 3 by n square pi square by L square minus 2 into sine of n pi by L into upper limit 2L by 3 by n square pi square by L square minus of minus plus 2 into sine of n pi by L into lower limit L by 3 by n square pi square by L square. Here L gets cancelled, here also LL gets cancelled, here also LL gets cancelled. Now upper limit, this is minus L minus L 0 into cos n pi by L into L. So 0 into cos n pi, therefore that value is equal to 0 by n pi by L, that becomes a 0. Minus of minus plus 2L by 3 minus L. 2L by 3 minus L, 3 is the LCM, 2L minus 3L, that is a minus L by 3 into cos n pi by L into 2L by 3 by n pi by L minus 0 minus L by 3 into cos of n pi by L into L 2L by 3 by n pi by L. Here LL gets cancelled. Now upper limit sin n pi by L into L by n square pi square by L square minus lower limit 2L by 3 sin n pi by L into 2L by 3 by n square pi square by L square plus sin of n pi by L into L by n square pi square by L square minus lower limit 2L by 3 sin of n pi by L into 2L by 3 by n square pi square by L square. Now here LL gets cancelled. LL gets cancelled. Now this is minus L by 3 cos n pi by 3 by n pi by L sin of n pi by 3 by n square pi square by L square L by 3 cos n 2n pi by 3 n pi by L and L by 3 cos of n pi by 3 by n pi by L minus 2 sin 2 n pi by 3 by n square pi square by L square. Now this is equal to 6h by L square into minus reciprocal L square by 3 n pi, L into L square by 3 n pi into cos of n pi by 3 now reciprocal L square by n square pi square into sin n pi by 3 plus sin of n pi by 3 into L square by n square pi square, here plus reciprocal L by 3 into L by n pi, L square by n pi cos of 2 n pi by 3 now plus reciprocal L into L square by 3 n pi cos n pi by 3 minus 2 L square by n square pi square into sin 2 n pi by 3. L square by n square pi square cos of n pi by 3 minus 2 times L square by n square pi square into sin of 2 n pi by 3 plus 2 sin n pi by 3 into reciprocal L square by n square pi square minus L square by 3 n pi cos 2 n pi by 3 plus 2 times L square by n square pi square into sin of n pi by 3 minus L square by n pi into cos of 2 n pi by 3 plus L square by n square pi square reciprocal sin n pi, that value becomes 0 minus sin of 2 n pi by 3 into L square by n square pi square reciprocal plus L square by n square pi square into sin n pi minus reciprocal L square by n square pi square into sin of 2 n pi by 3. Now here minus L square by 3 n pi cos n pi by 3 plus L square by here L square by 3 n pi cos n pi by 3, here only n pi 3 n pi. So by mistake here we have not written 3 and we write squares. Now this becomes a cancel and also L square by n pi cos 2 n pi by 3 plus L square by n pi cos 2n pi by 3. These two terms gets cancelled. Now here see that L square by n square pi square sin n pi by 3 and 2L square by n square pi square sin n pi by 3. These two terms becomes 3L square by n square pi square sin n pi by 3. And also here these two terms, see that minus 2L square by n square pi square sin 2n pi by 3 minus L square n square pi square into sin 2n pi by 3. That becomes minus 3 times L square by n square pi square sin 2n pi by 3 and sin n pi value 0. Therefore in these two terms and in these two terms we are getting 3L square by n square pi square, that is a common factor. So 6h into 6h by L square into 3L square by n square pi square is a common factor. This is equal to 6h by L square into 3 times L square by n square pi square into plus sin n pi by 3 minus sin of 2 n pi by 3. Now again this is equal to, here L square gets cancelled, 6h by n square pi square into, this can be written as sin n pi by 3. This can be written as sin of n pi minus n pi by 3. It becomes 3n pi minus n pi, 2n pi by 3. Now this can be written as 6h by n square pi square into sin of n pi by 3 minus sin a cos b, sin a cos of n pi by 3 minus of minus plus cos a sin b. By using the formula sin a minus b, sin a cos b minus cos a sin b minus of minus plus. Here cos n pi value minus 1 whole to the power of n, sin n pi value 0, therefore this term becomes a 0, and also sin n pi by 3 is a common factor in these two terms. And also here 6 into 3, 18. 18 h by n square pi square. Now this is equal to 18 h by n square pi square into sin n pi by 3 is a common factor, 1, here 0, plus cos n pi minus 1 whole to the power of n into sin n pi by 3 is a common factor. Therefore now this is the value of Bn. If n is an odd number, minus 1 whole to the power of n is a minus 1. Since minus 1 whole to the power of 1 is minus 1, minus 1 whole cube is minus 1, minus 1 whole to the power of 5 is minus 1, minus 1 whole to the power of 7 is minus 1. So 1 minus 1 is 0. This is equal to 0 if n is odd number, and also if n is even number, that is minus 1 whole to the power of 2 plus 1, minus 1 whole to the power of 4 plus 1, minus 1 whole to the power of 6 plus 1, minus 1 whole to the power of 8 plus 1. So 1 plus 1, 2. 18 into 2, 36 h by n square pi square sine n pi by 3. So therefore this is 36 h by n square pi square into sine n pi by 3. This is a Bn value. If n is even number, this is a Bn. Now substituting Bn in equation number 5. This is equation number 5. Here n is equal to 2, 4, 6, 8 and so on infinity. Since n is even number, Bn value 36 h by n square pi square sine n pi by 3 into sine n pi x by l cos n pi ct by l. Now substituting in equation 5, we obtain y of x comma t sigma n equal to 2, 4, 6 and so on up to infinity. 36 h by n square pi square into sine n pi by 3 into sine n pi x by l into cos n pi ct by l. Therefore, this is our required solution. Displacement of the string at any time t at any point x. Therefore, now this can be written as 246. Here put n is equal to 2m and write m is equal to 1 to infinity. So if you substitute n is equal to 2m, for example, n is equal to 2, 2 gets cancelled, m is equal to 1, n is equal to 4, 4 into 2m, therefore 2 ones, 2 twos, m is equal to 2, n is equal to 6, 6 is equal to 2m, 2 ones, 2 threes, m is equal to 3, that means m will take the value from 1, 2, 3 and so on. So wherever n is there, here we have to substitute 2m. Y of x comma t is equal to sigma m is equal to 1 to infinity 36 h by 2m whole square, that is 4m square, 4 ones 4 nines, so this is 9 h by m square into pi square into sine 2 m pi by 3 into sine 2m pi x by L into cos 2m pi ct by L. This is displacement of the string. In the given problem, he asked to derive an expression for the displacement of the string at any subsequent time. So now we derived the expression for the displacement of the string at any time. Now we have to show that the midpoint of the string always remains at a rest. Midpoint of the string, that means length of the string is L, so midpoint of the string is L by 2. Since the length of the string is L, half of the length is equal to L by 2, so that indicates the midpoint of the string. L by 2, x is equal to L by 2 indicates the midpoint of the string. There, what is the displacement? How much the displacement at the midpoint of the string? He asked to show that it is remains at rest. That means that value should be 0. Now we have to verify. Now put x is equal to L by 2 in the above equation. We get now y of L by 2 comma t equal to 9 is a constant here, h is a constant here, by pi square is also constant here, sigma m is equal to 1 to infinity 1 by m square into sine of 2m pi by 3 into sine of 2m pi by L into L by 2 into cos 2 m pi ct by L. Here 2 gets cancelled, LL gets cancelled, then it becomes sine m pi, m is equal to 1 to 3 and so on infinity, its value becomes 0. So therefore into cos 2m pi ct by L. This is equal to 0, since sin m pi is equal to 0. So displacement of the midpoint of the string is 0. Therefore, this shows that the midpoint of the string is always at rest. So the midpoint of the string is always at rest. Hence, the solution completes. We proved the expression for the derived the expression for the displacement of the string at any time t, and the midpoint of the string is also is at rest at the midpoint. Now, homework problem number 5. A string is tightly stretched and its ends are fastened at 2 points x equal to 0 and x is equal to L. The midpoint of the string is displaced transversely through a small distance b, and the string is released from rest in that position. Find an expression for the transverse displacement of the string at any time during the subsequent motion. So as in all the problems, a string is tightly stretched and fixed at the two endpoints x equal to 0 and x is equal to L. So it is tied at two endpoints x equal to 0 and x equal to L. Now at the midpoint of the string is displaced transversely. That means through a distance, a perpendicular distance b from its equilibrium position, we are displacing through a small distance b, and then the string is released from the rest in that position. From that equilibrium position, we are releasing the string after we stretched perpendicularly through a distance b from its x-axis. We have taken the string along the x-axis. Now we released. Then the string starts vibrates. There we get the one-dimensional wave equation. Now for this physical phenomena, find the expression for the transverse displacement of the string at any time during the subsequent motion. So as in the previous problem, here we are stretching the string at x is equal to L by 2, exactly at the midpoint L by 2, and then releasing the string. So as in the problem number 4, you solved the problem number 5 by yourself. Similarly, you can also solve problem number 6. A string of length L has its ends x equal to 0 and x is equal to L. A tightly stretched string of length. L has its ends x equal to 0 and x is equal to L fixed. The point where x equal to L by 3 is drawn aside a small distance h. The displacement y of x comma t satisfies the equation dou square y by dou t square equal to c square into dou square y by dou x square. Determine y of x comma t, displacement of the string at any time t. So here, as in the previous problem number 4, here also we are stretching the string perpendicularly through a distance, small distance h at the point x is equal to L by 3 and then releasing the string from that position. It is satisfying the equation and determine the expression for the displacement y of x comma t at any time. These two problems are homework. So these are the different varieties of problems related to one-dimensional wave equation. In the next class, we will discuss one-dimensional heat equation. There we can find the temperature function at any time t in the heat conduction along a rod.